So there's another MacSync sample that was discovered, this time by Jamf. And the reason I'm doing a quick video on this is because it's Swift, and that's always fun. So there's a write up here from Jamf. Shout out to Tice for sharing this on Twitter and writing this up. So what's most interesting about this to me specifically is they call out that it is code signed and notarized, right? So haven't seen a MacSync sample yet that is actually signed. So that's pretty interesting. And it was notarized since this report is revoked now. So that's awesome. But I want to spend some time talking about the specific Swift application because I think that's the most fun thing here. There's a lot of interesting things covered in the blog post that I'm not going to get into, but just to further our understanding of Swift, because it's a language that a lot of threat actors are starting to leverage, and yeah, just good to understand. So Tice does a good job here of explaining exactly what it does. We're just going to go into these functions a little bit and look at this from a ARM64 assembly perspective because of the way that Swift does things. It's kind of weird when you first look at it. So I thought it was a good opportunity to spend some time on this. All right, so shout out to Tice. Let's get started. Well, first, right, so they mentioned that it was code signed. I'm inside of the application bundle in here. Just some things that are interesting if you're looking into this. So the executable that we're going to be looking at right now is the runtime CTL. There's some weird characters in here. I'm not sure exactly what that is supposed to be. There's another one over here. I find the Apple events usage description pretty funny. This helper may request limited automation access to built-in macOS components to complete setup. It never collects personal data. That's just funny to me. But yeah, just wanted to shout that out. And also, of course, inside of the macOS directory, we have the actual executable. And we can see the code signature here that was mentioned already in the blog post. So something we don't really see often with these types of info stealers on macOS is actually like a signed application. So this ZK call and messenger installer, this version, right? And it just shows you like the entire path here. So this is a bundle. We're going to be looking at the ARM slice, right? So this includes both Intel and ARM. And here goes the dev ID and the dev name and the fact that it was notarized. So pretty interesting stuff. Again, it's almost Christmas time, so it's definitely a good time to spend some time with Swift. All right, so I have it opened up here in Binary Ninja. We're going to focus more on the assembly side of this because some of this stuff with ARM and Swift is interesting, and I just want to kind of highlight some of these. So let's start all the way here. So we have our function prologue. We're not too worried about that. First call is to the NS home directory. All right, so this is a branch and link instruction to this, which is then going to get the address of the NS home directory, load that into x16 using an ADRP and an LDR to actually get that symbol, and then it's going to branch and link to that. So all this is doing is executing this NS home directory, leveraging the x16 register. That's going to return this value, right? The home directory of the user into x0. So home user dir is an x0. Now we have like weird Objective-C like runtime stuff we don't have to spend too much time on, but essentially that x0 value, or the value in x0, is actually then passed into this BL instruction for Objective-C. This is like memory management, right? So retain auto-released return value. And usually when you see that, all that means is x0 is now going to get passed to this, and then it's going to be released here into x0 again. So this x0 down here after the BL instruction is going to be the user's home directory. That gets moved into x19. So home directory, home dir is now in x19. Okay, so now we have this weird symbol, and this symbol is for the like mangled function names in Swift. Now, if you run into this and you want to make this look prettier, there's a lot of tools out there for this, but essentially what I end up doing is running a plugin for this, the Swift Demangler plugin. And it's gonna just take a second. Might have to like reload this, and then yeah. So what this is going to do is going to pass the value that's an x0 into this, which is going to bridge from Objective-C, right? So this returned an Objective-C string, so an NS string. That value is passed in as an argument to this unconditionally bridged from Objective-C, and it's going to return a Swift string. Now, Swift strings are structs, so this is actually going to return into 2 registers. Shout out to Noir a long time ago for helping me understand this with Swift. So very grateful for that. But essentially, this is going to return into 2 registers, a pointer to the actual data, right, the string data, and then it's going to return the size of this Swift string as well. So that's why you see after this branch and link, we have the x0 and the x1 register both being used. That's usually a hint that they were written to by something. And then x0 is saved into x20 and x1 is saved into x21, and we'll see that in a bit. So if we look at the decompilation, we'll see we might be missing something. And I know that Vector35 and the folks over there, which are also working on some Swift stuff. But, you know, for now, kind of have to make some edits to make this code kind of flow a little bit easier when you're looking at it. So we know that x0 is going to get passed into this. This accepts an argument, but it is missing the fact that that argument is passed in here. And this would help us understand like what's going on. So at the top, we know this is going to return that home directory. So I'm going to change this object to user home dir. And notice we don't see it used besides this Objective-C release, which is going to release this object. And that's not true. It gets passed in here. So what we need to do is you can press Y, and we're going to change this type. And we're going to add the fact that this receives an argument, and we're using ARM here. So if we just put N64T arg1, we don't have to specify the actual register this is going to be pulling from. It knows it's going to be x0 because we're dealing with ARM. So accept. Now we see it passed in here. Okay, that's good. So again, our understanding of ARM and how this works can help us kind of like make this a little bit prettier. So we know that this is going to be passed in to this unconditionally bridged from Objective-C, and it's going to return a Swift string. So this is going to be part of that Swift string. All right, so we can just change this here in the decompilation, make it look pretty. User dir Swift, ooh, let me write that right. Swift string, and this is going to be the count. So Swift string count. Okay, so let's continue with the disassembly because I think it's pretty. And we now have this instruction, which is going to move that first part of this structure into x20, which we already talked about. So Swift string part 1 into x20, and then Swift string part 2 into x21. x19 had that object from the call to NS home directory that gets released. This is just part of, again, memory management. So this just means that NS string is released. You don't really have to pay attention to those, but just so that you understand like what's going on. You actually see that on decompilation pretty good. Okay, so these are saved here. Now let's continue. So we have an ADRP. This is going to load a page, right? The page is always going to end in a 0000, like a 1K page. So we get a pointer to this page, and now we're going to offset from that page into 0xe80. And essentially what we're doing is we're just adding so hex E80 to this initial page value. So we're getting an offset from this page, and that ends up being a variable that was that stayed when this was compiled. We actually see a home variable. I didn't change that. That gets loaded into, so a pointer to this page or this variable gets loaded into x22. So this is the home variable in x22. Let me make sure I got the right register. Yeah. Okay. And if we double click on this, we'll see right now home is equal to 0. And this is inside of the common section here, which is writable. And we can actually see other potential variables here that we'll see used. All of them are set to 0, right, upon this, being compiled. And then these are going to get dynamically filled with values as the sample runs. So right now, home is equal to 0. And again, it's just this address. Okay, so now we're going to store two values here. So we're going to now write the result of the user home directory Swift string to the home variable. That makes sense, right? And the way that you see this here is we have this add, which got a pointer to the home variable into x22. Now you're going to see a bracket. And when you see a bracket like this, it's like basically like dereferencing this pointer. So essentially, we're going to go to this address. We're going to use this address that x22 is pointing to, and we're going to do a STP instruction, which is store pair. So we're storing the value in x20 and the value in x21 at this home variable path, or this home variable memory address. And you actually see here the first part of this is stored in home, and then the second part looks like it's stored here, but this just ends up being the count. So this ends up being storing, let me write that right, storing home dir Swift string to the home variable, which makes sense. I mean, they named it home. Okay, so next thing, we already finished this one. We're going to move this value into x23, and then we're going to store another pair of register, whatever is inside of these registers, at SP on the stack pointer. So we're just storing 0 and this value, this 0xe, which ends up being, this is one part of a Swift, small Swift string, not a large Swift string, which we'll get into in a moment. It's always going to start with a 0xe, and then it has actual bytes that are written to in here in line. But we're just putting a 0, and this is basically a Swift string that's 0 for a small Swift string. So we're storing those two at this address at the stack pointer. We're going to move that reference to the stack pointer into x20 to use later. And now we're going to move this 0xd, which is 0xd is a dash, essentially, into w0, this value, and we're going to grow this, if you're looking at this in ASCII, and we're going to grow these string guts, which we're not going to really get into right now. So essentially, this is just like allowing this string blob to be bigger by that value. And we're going to continue here. So we have that state dir, or whatever this was, SP was at this SP address, but if you see this, this actually is going to add 8 to it. So this is going to reference this variable, which was this right here. If you move this over, 0xe, 0xe gets moved into x19 for later. Not sure what that's used for yet. And then we're going to load two values from x22. If we remember, x22 hasn't been overwritten, so x22 is still pointing to that same home variable. And Binary Ninja sees that like pretty easily here. It's referencing that variable. And x21 is now going to be loaded with that first part of that structure. And then x20 is loaded with that second part of that structure, which is the count. Here, we're going to bridge object retain. So x20 is going to be retained. It's moved into x0. That's just memory management for Objective-C or Swift here in this case. And then we're going to also release this value that we're no longer going to use. Okay. Now we're storing, so these now have been retained. So that's like reference counting and stuff like that. X21 has that first home variable, part of the user home. And now X20 has the count, and we're going to store those at the stack. Okay. So we moved the values from variable home to the stack. Not sure what that's used for yet, but let's continue. Oh, okay. So here, this gets a little bit complicated, but essentially what this is going to do is it's going to load a page. It's going to get a page, a pointer to X8. It's going to add this offset. It's going to subtract 0x20 from that offset. It's going to move this value of 0x12 into x24, and then do a move k, which keeps that value, that initial value. And it's going to move over using the left shift for 0x30. And essentially what this is going to look like when it finishes is like this. And this is one part of a large Swift string. You'll see this second part usually with this 0xd. This 0x12 is going to be the size of this string, which is 18 bytes. So first part of Swift string, or one part of Swift string, which equals 18 bytes long. Okay, so the second part of this is going to be a pointer that's going to have a 0x8 at the top of it. Hold on, this is going to move here. So that's one part of it. We're adding x19 to it. So this ends up being an even larger Swift string. So this might be the actual Swift string size. And then we're going to OR x8, this value, which is essentially going to put an 8 all the way at the top of this. And this ends up being a pointer to the bytes that are related to this Swift string, this large Swift string. Yes, you have to do some math to get it right. If you've seen any of my other videos related to this, you'll know that. So let's just show what this looks like here. Display as, so that ended up being the size of these strings, and display as this. And what you do is some math, quick math. So we're going to do a bv.read, bv.read. We're going to pass in this pointer value. Swift strings are kind of weird. With these large ones, you actually have to add an offset of 0x20, which is 32 bits, which you see a subtraction happens here earlier. And then we're going to pass in the size of this, so 0x2b, and that ends up being one of the first strings here that are going to be used by this sample. Library application support user sync worker. Okay, so there's an easier way of doing this. There's some pretty cool tools out there. At the recent OBTS, a friend released a whole thing about Swift strings and an entire like plugin to work with these. I just have like a quick script that I work with, which helps me kind of add these here. So Swift string parser. So this is going to add like those specific Swift strings, and you can see that one was already added there based on the fact that it was passed to this function. So what you'll see is this Swift string, this library application support user sync worker is appending. So it's being passed in as the argument for the append method against the string. But if you're not familiar with the way that Swift works, you may be wondering, what is it appending to? And what it's appending to is whatever value is in x20. x20 is essentially self. So like in C++, like self is x0, Objective-C, you have the object itself is an x0 and the selector is an x1. In Swift, when we're talking about ARM, it's an x20. So if we remember back here, we stored the values from the variable home to the stack, and now we move that pointer, that this, obviously the stack pointer is pointing to an address. We move that value into x20, and now we're appending to it. So essentially what this is doing is x20 dot append, and then I think I still have it copied, this, just like that. And x20 is equal to, or it's pointing to, the variable for home, which is the user home directory. So at the end of this, x20 is going to be pointing to, if I can type right, so what we would expect, oh, let me make this here. I put this wrong, home, but essentially user home, and then library application support user sync worker. So at the end of this, it's going to be this value. So let's just add this here. Oh, make sure I don't forget the X comment. Okay, that's fine. Okay, so now we have that same stack pointer that referenced to that same object here, again, that we changed. Now that's going to be loaded into x8 and x9. x8 now has that value. Now we're going to do something else. So remember, this has, so x8 now has the new path. And now we're going to do an ADRP. So we're going to get this page, right, ends in 0000. And we're going to offset that to this other variable, the state dir. Home already has user home. Oh, let me spell that right. User home. And then this has the count of user home string. Now we're dealing with this state dir here. So let's go back. This address is moved into x21, and now we're going to store two registers. So we're going to store this new path to this state dir. So state dir is now going to have this. So let's go in here, and I'm just going to add that as a comment. And again, this is going to be the size of the string. So that's going to edit this size of state dir. Oh, we'll just leave it like that. That's fine. Okay. So next thing, let's continue. We have another STP instruction, which is going to put two values onto the stack pointer. We already used the stack pointer. We're not worried about it anymore. We offsetted that. We loaded the values we needed. So now we're actually writing to this. And this is going to be a 0. And whatever is an x23, which I don't even remember what's an x23. Okay, it looks like x23 still has this value here. Oh, it's going to do another one of these string guts grow things. So we're not worried about that. Okay, next thing. So this has that. This is going to get retained. This is going to get released. This is the same thing we talked about before. What we're worried about is right here. So x22, which still has that pointer to home, since over here, and Binary Ninja, sees that reference here, which is great. And we're moving that into x23, and this is going to be the size of home. And now we're going to use that same stack pointer that we have here, and we're going to write these two values to the stack pointer again. So, and the same thing is going to happen again. So let's walk through this. We have the large Swift string that is getting set up, and we're going to reference this library logs user sync worker.log, and we're going to append to something, and that something will be the user home, which again is here. This is getting the state. I can change this variable name, but essentially this is going to be the user home. So this is going to equal, let's do it here. So user home, let me get that value first, which is right here. So after this append, right? So we're doing an x20 dot append, and we're passing in a string, and this is going to result in this. So x20 is this, and again, SP is pointing to that same thing. So SP is also going to point to that. And now we're going to load that value that we just modified on the stack into x8. And now we're going to use another variable. So they're just setting up variables for different things that they're going to use later, which makes sense. Now we're dealing with the log path, this variable, which makes sense because this is a log file that they're writing to. And essentially what this is going to do is going to set up, oh, I put the comment in there wrong, but that's fine. It's going to set up log path to equal that, right? And then this is going to be, we're not dealing with enums right now. This is going to be, we can actually probably make these into structs, but we're not going to do that right now. Count of log string. Go back. Okay, so continuing on, that does the log path. We store the values in x8 and x9. This is how it gets written to, because x10 is used as the pointer that has that reference to log path, and then we're going to write to that address using the stp instruction. And x21 has that same address for state there, it looks like. And we're then storing that at SP. Okay, so state there is moved in there later. And now we have what is a small Swift string. So large Swift strings are these like a little bit complicated way of looking at this, where we have something that starts with, we can see it here in a decompilation, right? So this is the size, 0x20, which is 32. And we have this, which contains a pointer to where this string is. You have to add an offset to that. Swift strings that are smaller than a certain amount of bytes that don't fit into 2 registers, so they'll be like 15 bytes and low because you need to be able to account for the size inside of those registers. They're actually passed in line. So this is what it looks like. We have the move instruction to move these bytes, and we can display these as what they are. 0x or E, right, /E. And then we have a move K, which essentially just moves over using this left shift, right, 2 bytes over, and then it writes more data into this register. And then we have another one that moves over, and essentially what it ends up looking like is this. So gate, which I believe is mentioned in the blog post at some point. And we're going to append whatever was in state dir at that time with the gate. So we're going to use that in x20 to then append gate to it. Okay, so continuing on, this is going to be the etag path. So the etag path is going to be written to with this gate, which is using that that other value that's in the state dir for gate here. So we're just going to add this here. So comment, I'll just put gate for now. It's fine. I just explained all that, so I don't want to go through all of that one more time. This is going to be more of these smaller Swift strings. And just make sure I'm doing this right. So last update is also going to be appended to the value that's in SP. SP ends up being that state dir. So we have the last update there as well. And that's going to be moved into this TS path, which is, again, is another path related to this. And I'm just going to put that in here. So gate or TS path. Oh, what was it again? Hold on, let me go back. Last update. Okay. I'm not adding the whole path, but that's okay. Last update. Okay, so that's how all of those like different variables were actually set up, which is pretty cool. If you look at this, you know, inside of the actual disassembly, it makes sense of it. Because sometimes some decompilations might make it a little bit more difficult to read. But after all those variables are set up, they actually have a function that logs that actually like logs this stuff. And you can see this here. It's starting update. And it does a check internet function, which is again covered by Tyson in the blog post by Jamf. But just really quick, I thought it was really funny what they do. Okay, so url.init, we're passing in a string. So this is going to initialize a URL, a Swift URL. And this string ends up being http http, www.apple.com. And they actually end up like basically creating this session, this net session to talk to apple.com and determine if it's actually connected to the internet. And the way they do that is inside of a block, right? So this is like a bunch of code here that's related to a block, and you pass a block as a completion handler for any kind of like network connection. So the way that this would look is, just to kind of go through it really quickly, we can see this selector here for shared session. This is going to reference a URL session. It's a pointer here inside of the Objective-C class references, which are referencing classes. Not sure why it doesn't just like write this over, but that's fine. We have this NS URL session. We can just change all these variables and make it prettier. Let's do that for this one. Okay, so this is going to create a shared NS URL session. So NS URL session. Okay, we're going to bridge to Objective-C based on some kind of URL. It's kind of hard to see this, but that URL is the URL that was initialized up here. So let's just put that in here. It's missing that value that's passed in, and it's passed in via X20, right? So this is going to be our Apple URL that's passed in. Okay, and then this is going to set up the block. There's some stuff here that's basically not highlighted, but essentially what this is going to do is it calls a function as a completion handler when that connection actually occurs. And we see a partial apply for a closure 1. So closures in Swift are just like code that you can pass around pretty easily. And you can see this here, partial apply for closure 1 in check internet. So if we double click on this, we'll see what they do with that network connection. And we can, without understanding the variables or anything like that, we can kind of make sense of it really quickly. So we have this object for NS HTTP URL response, or a response object. Let's change this to be this so it looks prettier. Go back. This is going to do a dynamic cast based on whatever values in arg3, which we're not really worried about. This is going to be the response. URL response. So that object is checked, and that NS response object is passed this status code method, and this check is 200. I think this is probably 200. Yeah. So if it's equal to that status code 200, so essentially this is just checking to see if it was able to talk to apple.com, which I think is pretty funny. Okay, so going back, this is going to check the internet for that to see if it actually has a network connection. Why? Because it wants to make a curl request, of course. So let's go back to main. Check if you can talk to apple.com. Okay, and I mean, that makes sense. I guess you can kind of like bypass certain types of, if you're looking at network stuff. I mean, our devices, these Apple devices, talk to Apple all the time. So maybe that's a really smart way of doing it. So then we have this run installer function. I'm just going to kind of walk through this really quickly because of the parsing of the Swift strings. We should get a blob of data. Yeah. Okay. So here goes the C2. We can see all this like being appended into this huge command that's going to get executed at some point. But we can kind of see all this information here that was referenced in the blog post. We have this curl command, all these headers related to this curl command, and then that gets executed. and all that fun stuff. And it looks like it probably writes it out to this like runner.code in a temp directory. But yeah, so just a quick recap on that. Didn't want to spend too much time on the run installer. Wanted to just cover some of this Swift stuff from an assembly perspective because it's pretty. And just to kind of recap, these values, these variables that are inside of this section of the binary, which are, again, is writable, are modified after execution. And then these are then going to be passed around. We can see like this home directory is inside of the main function. But if we reference any of these, this one is going to be used inside of the run installer at some point. The log path is used inside of the log function, which makes sense. They're going to write logs here, which I guess that's good. And then you can see all the references to these different values that were set up after execution. Because again, when this started, they were all zeros. All right, well, that's it. I think these samples are fun. I really enjoy Swift. Hopefully that's helpful for anyone who wants to look at Swift. And I'll catch you on the next one.